There are typically three methods used for providing a concrete encased electrode. The two most common are firstly, a length of bare number 4 copper, usually solid, but occasionally stranded, is placed in the footing so that at least 20 feet runs parallel with the footing rebar. This is usually loosely draped around a rebar and is sometimes clamped to a rebar, sometimes not. The other end is long enough to come out the top of the foundation. Usually it is long enough to reach and splice to the disconnect enclosure. In this approach, the number 4 copper wire is a National Electrical Code legal concrete encased electrode, and the contact with or clamping to the rebar is just added value. Secondly, a length of number 4 copper conductor is clamped to the rebar in the footing and run out the top of the foundation. Often this conductor is long enough to run unspliced to the disconnect. In this approach there is no particular length of the number 4 copper that runs along the length of the footing. In this approach, the number 4 copper is a grounding electrode conductor and the footing rebar is the National Electrical Code recognized concrete encased electrode. Thirdly, a less common method is to bend a 20-foot length of footing rebar so that one end comes out of the top of the foundation. The lower leg of the bent rebar is tied to the rest of the footing rebar with the usual wire ties. None of the described approaches appear to violate the National Electrical Code. Method 1 complies with National Electrical Code section 250.52. A3, which allows for a single bare copper conductor not smaller than number 4 American wire gauge to be embedded in concrete. The contact with the footing rebar provides additional grounding protection. Method 2 complies with National Electrical Code section 250.52. A2, which allows for footing rebar to be used, is a concrete encased electrode. The number 4 copper conductor serves as a grounding electrode conductor, connecting the footing electrode to the electrical system. Method 3 also complies with National Electrical Code section 250.52. A2. The bent rebar serves as both a concrete encased electrode and a grounding electrode conductor. In terms of long-term performance, there is no clear consensus on which method is superior. However, there are some considerations to keep in mind. In Method 1, the exposed copper wire may be susceptible to corrosion over time, especially in areas with high moisture or corrosive soil conditions. However, the concrete encasing provides some protection. In Method 2, the number 4 copper grounding electrode conductor is less likely to corrode than bare copper wire, as it is covered with insulation. However, the connection between the grounding electrode conductor and the footing rebar may be a potential point of failure over time. In Method 3, the bent rebar provides a direct and permanent connection to the footing electrode, eliminating the potential for connection failure. However, it may be more difficult to test the continuity of the grounding path using this method. The green copper oxidation film is a conductor, but its conductivity is much lower than that of bare copper. Over time, oxidation may reduce the effectiveness of the electrode, especially if the oxidation layer becomes thick. However, the concrete encasing provides some protection against oxidation, and the National Electrical Code allows for a minimum of 20 feet of bare copper conductor to be used, providing a sufficient surface area for grounding. While all three methods are compliant with the National Electrical Code, it is recommended to use Method 2 or Method 3 for the following reasons. Method 2 provides a more reliable and long-lasting connection between the grounding electrode conductor and the footing electrode. Method 3 provides a permanent and direct grounding path, eliminating potential points of failure. If Method 1 is used, special attention should be paid to the quality of the copper wire and the protection of the exposed portion from corrosion.